Welcome to episode 8 of the design series, creating a custom computer case for a NAS with SOLIDWORKS xDesign. In this series, we're transforming standard PC components into a fully functional network-attached storage with a 3D printed case. Don't worry if you've missed previous episodes, links are in the description below. In the last episode, we added Star Wars theme to this computer case, with front panel inspired from interior of Empire spaceships and side panel inspired from Death Star surface. In this episode, we finished the design with remaining panels I chose to make in Plexiglas, including the panel that will hold solid-state drives. Is it the last episode? We will see at the end of this video. So let's start with measuring the case so I can design panels correctly. We have defined upper and lower sides as equal, so I measure only bottom one. I can make large panels as they won't be 3D printed, they will be cut in Plexiglas sheets. Next, I measure top face and I check length, but no surprise, this is the same as side panels. So again, an extrusion will be the solution, and I remove 2 mm from the measurements to give the same 1 mm clearance on each side than the other panels. I also leverage symmetry to create holes with mirror feature on each corner, using a line from middle points on side edges. Now you know the trick. Then I add fillets, but I won't create them on Plexiglas parts, this would be too risky as Plexiglas is too brittle. As always, I mate the part with a plane and two distances of 1 mm as explained before. A control drag and I get a copy that I can mate to the assembly with same mates behind motherboard. I create a new instance for the panel holding SSD as it will be different. Of course, I mate it with same mates than before, you get used to it now. I will do the same for top panel. I save as a new part and I change width. I mate in position with usual mates and part is in place. Once all panels are ready, I take care of solid drive's position. For that, I project their mounting hole positions into a sketch, and you know the trick now, I take dimensions to remove external references. Once this is done, I recreate some rectangles with accurate dimensions and use them to create 4 mm mounting holes. However, as I won't screw drives directly on Plexiglas for cooling purpose, I will install spacing columns. But this time this won't be metal spacing columns as the ones we used for motherboard, this will be plastic ones to be used also as dampers. I can still use metal ones and save them as new parts, as geometry is the same. Only height will be different, so I change it. I also change color so there will be no doubt during assembly phase. Once I have inserted all spacers I need, I position them in the assembly between panel and solid drives. I finish with transparency on parts, with a material, not with transparency tool that is only a temporary visual property that has no effect on part itself. Now the assembly is finished, isn't it? Let's finish assembling parts together. I start with adding spacers on solid drives, then I fix them on the panel. Actually, this is the only way. But once cables are attached, I realize I cannot put the panel in place. Cables are blocked by middle bar. This is not a good start. Fortunately, I can position all other transparent panels, at least something works fine. I also remove cables so SSD panel can be secured. But in this state, NAS won't work, so this problem needs to be corrected if I want to use it. And I want to. This will conclude this episode, but not the series. As in the next episode, I will realize some major issues prevent normal usage of this product, and I will start solving some of these major issues. If you want to create your own models for a 3D printer, check out SOLIDWORKS for Maker's website to subscribe to xDesign for low price and start designing today. Thanks for watching and see you in the next episode.